Welcome back. All right, so tonight or today or right now, what we're going to be going over is we're still in Unit 3. We're going to look at measures of center. This is, again, out of Chapter 21. We're going to be looking at Section 2. This is measures of central tendency and dispersion for what's known as ungrouped data. So our goals for this particular section, we're going to look at several things. We want to identify and use the formula for finding a mean. We're going to identify the mean formula and its different parts. We're going to use that formula to calculate mean. We're going to use the mean formula to calculate a missing point. And then we're going to be able to identify and calculate a weighted average. All of that under the idea of a mean. We're going to be able to identify and calculate a median for a set of data, whether that set has an even number of data points in it or an odd number of data points in it. We're also going to take a look at mode for a data set and determine if a set of data has no mode, a singular mode, or if it is bimodal. And then lastly, we want to be able to identify and calculate the range for a set of ungrouped data and put all of these things together so that when given a set of data, we will be able to find the mean, the median, the mode, and the range. And using some of this information, we want to take that one step further and use that information to form an opinion about truthfulness of a statement. All right, so you are likely already familiar with what an average is, that it's a numerical value used to represent an entire set of data. In other words, we don't give you each individual data point, but instead we say, oh, everybody in this college is 27. That doesn't mean everybody is 27. It just means the average is 27. Statistically, we call this the mean or the arithmetic mean. We find it by taking the sum of the values of the data set and dividing it by the number of values in the set. So this is how we calculate a mean. There we go. You find the sum of values and divide that by the number of values in the set. Now, there's a formula, and that formula looks like what you see in the blue here. It's the mean is equal to, and you have that sort of E-looking thing. That's a Greek letter. It's called sigma, and that means the sum of. In this case, it's the sum of all the x's, where x is representing a single data point. So it is the sum of all data points, dividing it by n, where n represents the number of data points in the set. So what does that look like? I have two examples here. The first example gives us the attendance figures for a series of seminars. They are 342 people, 247 people, 661 people, 418, and 512. What was the average number of individuals attending per seminar? So what we want to do is we want to take the sum of all of those values and divide it by the number of values. Again, this would look like the formula, the sum of all x's divided by n, where our x's would be the 432, the 247, the 661, the 418, and the 512. And we would simply, using our calculator, add all of those up and then divide it by 5, because there are 5 data points in this set. That would give us 2,270 divided by 5, or 454. This tells us that on average, there are 454 people in each seminar. This is important if you need to know how many people are on a Zoom call, or if you're trying to maybe book a room at a hotel in order to speak to this convention. You need to know how many seats you need. All right, so let's say WW Worldwide Travel had a daily sales of $4,635, $3,655, $3,506, $2,870, $4,309, and $5,475. What are the mean sales per day? You may want to know, if you're the owner of Worldwide Travel, how much you're selling on average, or your mean sales for the week, for the day. So we're going to do the same idea here. We're going to sum up all of those values and divide it by the number of values. Again, that formula will look like the sum of all x's divided by n, where the sum of all x's simply means add up all your data points, and n is the number of values you have in this data set. Now, for this data set, there are 6 days. Sounds like they're not open one day, but there are 6 days that we're adding up, sales for 6 days, and we get a total of 24,450 divided by 6, which works out to be 4,075, or $4,075 per day. Now, this is just the basics of how to calculate the mean. If you're already familiar with this, that's fine. I'm going to throw it for a loop here. And what we're going to do in this next example is we're going to go ahead and use the mean to find a missing data point. When would that happen? Well, sometimes you get ahead of yourself. So the average score for 7 students on a Unit 1 test was 85%. But for whatever reason, I only have the scores for 6 students. Maybe I lost a test. Maybe I forgot where I put it. But I need to know what that 7th student's test was. So knowing that I have 6 scores of 68, 79, 83, 86, 90, and 95, what was the score of the 7th student? Now, in real life, I might offer a couple of different opportunities. Now, I also know how to do the math on this, so we're good. All right, so here's what we need to remember. An average of 85% means that we can assign each of those 7 students an 85. Some will have scored above it, some will have scored below it, but in general, the total of all 7 scores would be the same as if each of those 7 people got an 85. So if I take 7 times 85, I will have the total of everybody's points earned. So 7 times 85 is 595. I know 6 of those scores. So if I subtract off each one of the 6 I know, I'm going to be left with the 1 score I didn't have. So we're going to take 595, which is the total if everybody got an 85, and then I'm going to subtract off all the scores I know. Now, I can subtract them off individually, or I can add up all the known scores, find that total, and then subtract it off. So 595 minus the 501, which is 94. So the missing score here had to be a 94. I have a second example that is similar. We have a car dealer who sold 10 cars, and he knows the average value of those cars is $28,000. 3 of the cars he sold for $24,000. 3 of those cars were sold for $30,000, and 3 were sold for $32,000. We want to find the value of the unknown vehicle, because 3 and 3 and 3 is only 9, which means we have the value of 1 vehicle missing. So we're going to use the same process. An average of 28,000 means that we can assign 28,000 to each of the 10 cars. And that means that 10 times 28,000, or 280K, is the total amount of his sales. Now, I know he had 3 of each kind. 9 car prices I know. So if I add up all of those known prices and subtract them from the 280K, I'm going to get the price of the car I didn't know. So adding those all up, I get 280,000 minus 258K, or $22,000 as the missing price. I can check that answer. Whoops, let me check that answer. I think I just got to click on it. Yep, 22,000. All right. Now, this is one that you might want to pay attention to. This is called a weighted average. This is actually how I calculate your grade. Not all points are the same. So a weighted average assumes the value of a category is average. And then you multiply the number in that category by its weight. It's used for GPA. If you're in a business, you can use it for inventory valuing and for cost analysis on items. There we go. Okay, so here's what a weighted average formula looks like. Ooh, you take category times the value, you add it to the next category times the value, you add that to the next category times the value, and you keep going until you run out of categories. Then you have to divide that by the sum of all the categories. What does that look like? Well, in order to have it be a little bit more applicable for you, let's take a look at how we calculate a GPA in college using your weighted average. So Carla received her grade, and she's got to determine her GPA. You can see her elementary algebra was 4 credits, and she got a B. Her study skills class was only 1 credit. She got an A. Her comm skills class is 3 credits, and she got a B. And her Adobe class is 3 credits, which for whatever reason she unfortunately did not do so well in. The standard category weights are as follows. An A counts for 4 points, a B counts for 3 points, a C for 2, a D for 1, and an F for 0. This scoring of A is 1, B is 3, C is 2, D is 1, and F is 0 is fairly standard. It's called a 4-point scale. The part that you need to understand, well, hold on. Let me back up a minute. Is Carla full-time? Is she a full-time student? Would she be considered a full-time student here at Western? Well, at Western, full-time is 12 credits. Carla has 3, 6, 10, she has 11. So would she be full-time? Okay. The credits are important because these are our different categories. What you need to understand, what we need to pull in as information here, is that a grade of B in a 4-credit class means that B counts 4 times. That's just not one B. In a 4-credit class, you've received that B essentially 4 times. So if a B is 3 points, you've gotten 3 points 4 different times. So the total amount of points awarded here is 4 times the B, which is 4 times 3, or 12. The study skills class is an A, but it was only 1 credit, which means you don't get that A awarded but 1 time. So you only get 1 times 4, or 4 points for that class. The communication class was a 3-credit class, and Carla received a B. So that B counts not once, not twice, but 3 times. So 3 times 3, because a B is worth 3 credits, is 9 points. She will receive 9 points for her B in that class. The Adobe class was an F. It's worth 3 credits. So that F is not 1 F. That's 3 Fs. The 3-credit class means that F counts 3 times. So 3 times F, or 3 times 0, means she will be awarded 0 points for that class. Now, how do we find the grade point average? We take the total of all of the points, the 12 from elementary algebra, the 4 from the study skills class, the 9 from the communication class, and the 0 from the Adobe class, and we add all those up. That's the total of the graded points. We then have to divide that by the total number of credits. So this will be the 12, the 4, the 9, and the 0, but I need to divide it by the total of 11 credits that she's taking this term. That means that her GPA is a 2.273. So she didn't even make the B honor roll. Oh, darn it. Okay, now imagine for a moment that, let's come over here. Let's imagine for a moment that she didn't get an F here. She got an A. Let's imagine she had done well in that Adobe class and gotten an A instead of the F. If that is what had happened, oh, lost it, there we go, then this would have been not 3 times 0, but 3 times 4. And that would have given her 12 points on that. Now, with 12 points on that, we've got a new total. 12, 24, 28, that would have given us a 37 over 11. And that would have changed her GPA to be a 3 where's my calculator? On my calculator, we're going to do 37 divided by 11. 3.364 or 3.36, which is much better. So she had just been able to switch one class. She would have done all right. As a matter of fact, I'm just going to switch it up one more time, and I'm going to say, okay, what if her F had been here? So if that was the case, we would have had a 12, a 0, a 9, and a 12. Plus a 0 plus the 9 plus the 12. And that would have given her 24. That would have given her a 33 over 11. She still would have made the 3.0. So what is the lesson here? The lesson here is if you need to prioritize your classes, prioritize the higher credit classes first. That's the bigger lesson. All right. Business-wise, where might we use a weighted average? Business-wise, you might look at the cost per item in a store. So take an example like a dollar store. The whole point of a dollar store is that everything costs $1. But it doesn't really. There are things in a dollar store that cost more than $1, and there are things that will cost less than $1. Not that you pay, but that costs the store more than $1 and less than $1. The idea here is that the store has a market or has a target that they don't want the average cost of an item to be any more than whatever their markup is. Maybe it's 70 cents. This is not a foreign concept to a lot of stores. A lot of stores will say our average price point is this. For example, the average price point at Walmart is generally lower than the average price point at Target. And so this calculation is done using a weighted average because there are thousands of items in a store. Nobody wants to add those up individually. So here we have sort of a shortened version of that. We've got 5 items, and I've got an item count as well as a cost. So I'm really using just a regular average, but I'm modifying it a bit for categories. So we're going to take the total cost of all the items and divide that by the total number of items. So for each of these categories, for item number 45,287, we're going to do 142 of those times the cost of $11.65. So I now know there's $1,654.30 wrapped up in that one item. The second item has a count of 228 times $2.25 for $513. Then I have 550 times 15 cents. That's such a little cost. It makes me wonder if those are the bracelets that are always at your checkout. Then I have 227 times 75 cents and 132 times 12.50 for 16.50. I need to add up all of those total costs, the cost for each category. So I'm going to take 16.54 plus 1654.30 plus the 513 plus 82.50 plus 170.25 plus 16.50. And then I need to divide all of those by the total number of items. Now, the total number of items I'm going to find by adding up the count. So I want to add up everything that has a count. So I'm going to add up the 142, the 228, the 550, the 227, and the 132. This gives me a 4,070.05, divided by 1,279. This gives me a per item cost of $3.18. And that is a weighted average for the inventory. Doesn't mean everything costs $3.18. It means the average of all the items in the store is $3.18 per item. Okay, we've now met our goals for the averages, most of them anyway, for mean. So we're going to talk about what a median is. The median is the midpoint value on a set of data, but only after the data has been ranked in order, either ascending, which is from lowest to highest, or descending, which means it's ranked from the highest value to the lowest. You know, you've done this when you've searched on a site like on the internet for something, either Amazon or Wayfair or whatever, and you have it sort by price. Ascending means you start with the lowest price and go up, and descending means you started with the highest price and you're going down. All right, so how do you determine the mean? First things first, rank the data in order, either ascending or descending, it doesn't matter. Second part is you need to identify the middle value. For an odd number of data points, 3, 5, 7, 9, 731, odd, ends in a 1, you need to know that the median will be the value in the middle. You've lined everything up on the left, you've lined everything up on the right, and there's one number in the middle yet. That's your median. If you have an even number of data points, then you don't get a middle point, you actually get 2 middle points, right? You lined everything up and it'll break evenly in the middle. So there won't be a single data point in the middle, there will be 2 data points in the middle. So the median will average those 2 points. Let's try a couple here. Okay, so here I have a data set. I'm using a small one so it's manageable, even though the numbers are big. I have 1, 2, 3, 4, 5, 6, 7, 8 data points. So I first need to rank those. I'm going to rank them in increasing order. So in increasing order, my first data value would be 1,220. Then we're going to do 2,430. 3,619, 4,237, 4,589, 5,840, 6,558, and then 7,001. Now, to find the middle, we can use elimination, which means I'm going to go from end to end. I'm going to mark off one on the far left and one on the far right. And I'm going to just lightly mark through those data points. I'm going to keep doing it until I have a middle. You see that there are an even number of data points, so there are 2 points in the middle. The median is then going to be right between those 2. How do I find what number is right between those 2 data points? I take the average. The median would be 4,237 plus the 4,589, and I divide that by 2. And if I do that, I get the number 4,413. That would be my median for this data point. Now, the interesting piece here is that 4,413 was never a data point to start with. That never came up. But the median can still be a number that isn't in the data. I know, mind blown. Okay, let's try another example. Whoopsie. where we have an odd number of data points. So here I have 1, 2, 3, 4, 5, 6, 7 data points. There is an odd number of data points, but I still need to do the order. So the first thing I want to do is go ahead and rank them in order from increasing the lowest first. All right, lowest number is 9. Then we have 10. Then 15, 22, 65, 72, and 90. Again, we can use elimination to find the middle. So left side, right side, I'm going to cancel out 1 on each side. I'm going to do the same thing until I get to either 1 or 2 middle points. In this case, we had an odd number. So that single point that's left in the middle, that is our median. So for this guy, our median is 22. All right, that's median. I like to think of it as like the median in the road is the one right in the middle. The hard part with median is you must order it. And if you don't put it in order, there's no guarantee that what you have is the median. All right, then we have the mode. The mode is the value or values in a set of data that occur most often. I remember mode as being most often because the M in mode is like most and then O for often. So mode is M-O-D-E or M as in most, O as in often. I know, but whatever works. All right, so how do you determine the mode? It's really just a count or a record. You count or record, sorry, not a record. You count or record the number of times each unique data point shows up. And then you have 3 options. If no data point shows up any more often than the rest, you don't have a mode. You just don't have one. If one data point shows up more frequently than any of the rest, then that is the mode. And the third option for this course is if you have 2 data points who are sort of tied for coming up the same amount of times, then you have bimodal data. Bimodal data. In other words, you can have 2 modes. Now, for the data sets that we use, if you have a 3 or 4 or 5 data points that all come up the same amount of times, we call that insignificant and we go back to no mode. We don't have large enough data sets to support having 3, 4, or 5 modes. Ours are 0, 1, or 2. Okay, we're not dealing with thousands upon thousands of pieces of data. So we're not doing those. Okay, so how do we determine the mode? Here we have a set of values that are meant to represent the size in gallons of fish tanks sold in a pet shop. So we've got a 10, a 20, a 10, a 10, a 55, a 20, a 10, a 10, a 65, an 85, a 20, a 10, a 20, and a 55. Did I say those fast enough for you? The first thing we want to do is go ahead and put those in order. And when we put them in order, it's easier to count how many of each. So we're going to determine how many times each of them shows up. The 10s showed up 5 times. 20s showed up 4 times. There we go. 55 showed up twice, 65 once, and 85 once. So, did any of these data points show up more frequently than the rest? Well, the 10, because it occurs 5 times, occurs more than any of the other data points in this set. So 10 then would be our mode. Okay, if, for whatever reason, we switch this data up a little bit, and let's say, oh, that 55 was wrong, and that really should have been a 20, then that would have also given us 5 20s, and 5 10s, and also 5 20s would have made this bimodal, because I'd have 2 data points, the 10 and the 20, that showed up the same number of times. Okay, moving along. Last one. This is a measure of dispersion for ungrouped data. We're actually not finding a center here. This is range, and it actually tells us the difference between the lowest data point and the highest data point. And this is a measure of how spread out, disperse, spread. how spread out the data is. Now, we're going to come back to range again, but I just want to be clear that the range is found by locating the highest and the lowest data point and subtracting them. So when you're given a set of data, like this range of temperature readings, you would want to put them in order. Now, sometimes for very small groups of data, you don't have to really put them in order to find the range, but it is a good idea if it's anything over like 5 to 7. So I'm going to put this in order. The lowest number is 349. The highest number is 369. So the range is 369 minus 349. This gives us 20. You actually find the difference. This is the part about range that sometimes people mess up on because we're used to using range as a low number, high number sort of situation, right? The range of ages is 14 to 24. Nobody says 10 years. Statistically, range is just the value between the highest and the lowest, not the lowest number slash highest number. So our range here is the 369 minus the 349, or 20, and that's what we use as range. Okay? All right. We're a half hour in, but I got 2 major examples left. Here we go. So, let's say you're the manager of a production plant, makes computer hard drives for Digital Storage Corp. Last month, your plant had the following numbers during a 15-day run. So they were able to make the following number of hard drives. So 2,456 on the first day, 3,504 on the second day, 2,845 on the third day. You can see how each one of these cells represents the number of hard drives created on each of those days. Now, in order to be able to work with the data, one of the first things we want to do is to go ahead and put it in order. So I'm going to order this data. I'm going to go quickly, but I hope you can see that this can be one of the most painstaking parts and one of the biggest traps. Because if you forget a number or if you flip digits, if instead, for example, of 2,456, I did 2,465, that could cause an error. So we want to be careful about this. And I'm just going to flip through these. The lowest is 2,368. I'm going to go ahead and put them in order from lowest to highest. And then what we're going to do is we're going to find the mean, the median, and the mode for this data set. The mean, if you recall, is the sum of all the values divided by the number of values. I have 15 different values, so 15 is my n. And then I need to add them all up. Now, when you have a data set like this, your calculator is going to run out of room. I have found most frequently that it's helpful to just go ahead and add up the first row. And if I add up that first row, I get 12,543. And then I'll add up the second row and the third row. And now in my calculator, rather than typing in 15 different values, I can simply add up those 3 values to get 51,859, which I'm going to divide by 15. This gives me 3,457.27. So that tells me that there were approximately 3,457 computer hard drives made each day. My median would be the number in the middle. And since there is an odd number of data points, it will literally be the number in the middle. So canceling from highest to lowest and back, I can go ahead and cancel the 4 on the bottom and the 4 on the top. And then bam, 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 bam. And I'm there at 2,742. The mode would be the number that shows up most frequently or most often. Each one of these numbers only shows up one time. I don't have any repeats. So there is no mode in this. None at all. Now, which of these three measures, the mean, the median, or the mode, would best describe daily production at your plant? The average is 3,457. Are you making 300, or is the plant making 3,457 on average? Is that average, or is that mean, representative of what your plant does on a daily basis? What about the median? Is the median a better representation of what the plant does on a daily basis? Think about it in these terms. Would you want the higher-ups to set you a daily goal of 3,457? Or would you want them to set you a daily goal of 2,742? Which one is actually done more frequently? Is there a mode? Well, there wasn't one, so maybe that wouldn't be. And then my challenge to you is to attempt to defend your answer using the data you have. Explain in words why you would choose the mean or the median or the mode as the best representation of the data. All right, here I have a second one, which maybe you'll see a little bit, maybe it'll bring some more questions up. All right, so according to Glassdoor, that's a website that posts salaries. Full-time Walmart employees make about $27,000 a year. At our local Walmart, the following salaries were released for 100 full-time employees. So, a store manager makes approximately $200,000. An assistant manager makes about $60,000. The department managers, $35,000 on average, and the cashiers or sales associates that are full-time are averaging about $25,000. Now, this is important. We have to break down the number of each position because there's not going to be 100 store managers making $200,000 a year. There are, in this case, let's say 2. There are maybe 6 assistant managers and maybe 12 department managers. That means that there is left 80 full-time positions for cashiers and sales associates. In order to find the mean, we're going to again use what's known as a weighted average. We're going to take the 2, well, we're going to find the sum of all of the data points and divide by the number of data points. Same thing a mean is. Okay, so we're going to take the 2 store managers at $200,000 and recognize that that's $400,000. The 6 assistant managers at $60,000 would be $360K. 12 department managers at $35,000 would be $420,000, and 80 sales associates at $25,000 would be just $2 million. So in order to find the sum of all the data points, I'm going to add up all of these different salary amounts for each category. And I'm going to divide it by the number of salaries that I've included. And since I've included 100 salaries, this is going to be $3,180,000 divided by 100, or $31,800 per person. So this is saying that just under $32,000 is the average salary at this Walmart. The median for this and the mode for this are a little bit harder to find. There are 100 people included in this. So where's the middle? The median would be the 50th and the 51st person, right? How am I getting that? Imagine 100. You'd have 50 on the left, 50 on the right. So that would be the 50th person and the 51st person. Those would be your middles. Now, the problem is that the lowest salary incorporates 80 people. So if I range this from lowest to highest, I'd have 80. The first 80 would all be 25,000. So that means that my median would have to be 25,000. My mode is the one that comes up most often. And the one that comes up most often would be the 80, 25,000. So my mode there is 25,000. All of this is well and good until the local Walmart boasts that it has a higher than average full-time salary. So I ask you, are they misrepresenting this data? Is their full-time salary higher than average? Do we even know how many employees are not full-time? Because if we had that information, that might say something about getting hired. If we're only counting 100 people here and they've got 800 employees because they got 2 full-time store managers, maybe they've got 800 employees and 700 of those employees are part-time. If you get hired on, there's not even a guarantee you're going to get a full-time salary. These are all just things to think about. When we give data, we're really only giving a small piece of it. Okay? If you would like to practice some of these before doing your assignment, you can go to Chapter 21, Section 2 Review. I'm sharing with you here my love of Doctor Who. So that's why you're seeing the TARDIS. There is a graded assignment on WebAssign. Its title is Chapter 21, Section 2. I didn't go real creatively there. Okay. And that squeaking, if you're hearing it, I think you're hearing it. That's Romy. He's found a toy. I just got to talk over him. All right. If you need any help, if you have questions on anything, please don't hesitate to contact your instructor or your math support or pop into the math center. Thank you.